Attention everyone, we're about to witness one of the most anticipated and unusual Starship missions yet. This is Flight 12, the first test of the V3 Starship, a version packed with major upgrades for long-term success. Yet it must also deliver immediate results to keep the program accelerating, making this one of the most critical launches in Starship's history. As always, SpaceX and Elon Musk have prepared with precision and secrecy, working behind the scenes on what could mark a breakthrough for reusable rockets and deep space exploration. So what exactly is SpaceX preparing for this flight, and what will determine its success? Let's find out in today's episode of Great SpaceX. Our next major milestone in the Starship development journey will be Flight 12, the highly anticipated first flight of the Starship V3. This mission is shaping up to be unlike any test we've seen before. The uniqueness of Flight 12 does not come from how SpaceX will conduct the flight itself, but from the many new factors and systems that will come into play throughout the process. Since this is the first V3 flight, the overall mission profile will remain familiar. The vehicle will lift off, climb to the upper atmosphere, and separate into two stages. The Super Heavy booster will return and attempt a controlled descent, most likely ending with a soft landing in the ocean. Meanwhile, the Starship upper stage will continue into orbit, deploy its payload, perform additional in-space demonstrations, then re-enter Earth's atmosphere and attempt a controlled landing. In short, the flight plan will simulate most of the procedures from the recent V2 flights, but without attempting to catch either stage. This approach allows SpaceX to safely validate the new version before attempting more complex recovery operations. However, the real difference, and the reason this flight is so exciting, comes from the upgrades themselves. These improvements represent the core of the secret plan that Musk and SpaceX have prepared to push Starship toward full operational capability. Let's begin with the most visible change, the launch site. For the first time ever, Starship will lift off from Pad 2 at Starbase, a completely new launch pad that has never been used before. We will no longer see SpaceX's massive rocket rise from the six-legged platform paired with the inverted shower water deluge system. Instead, this debut will take place on a redesigned pad featuring a box-shaped OLM supported by a dual-flame trench system. This upgrade marks a major step forward in reliability and reusability. The new mount is expected to provide greater structural stability during liftoff, while the dual-flame trench underneath will help deflect exhaust gases away from the vehicle and protect the pad from extreme heat and pressure. These changes are designed for the long term, as Starship's power and launch frequency are expected to increase dramatically in the years ahead. By moving beyond the pad structure, SpaceX has also implemented several ground system upgrades. The chopstick arms on Pad 2 have been shortened and reinforced to better accommodate the V3 Starship. During Flight 12, their main role will likely be to lift and hold the vehicle during stacking, but in future flights, they will play a vital role in catching the returning booster and ship. Below the surface, SpaceX has also made major adjustments to the tank farm and fuel delivery systems. It remains unclear whether the company will rely on a smaller dedicated tank farm near Pad 2 or connect it to the larger system at Pad 1. Regardless, recent pump replacements and fuel line upgrades suggest that SpaceX is improving its fueling capacity to handle the expanded propellant needs of the new vehicle. Starship V3 features slightly larger tanks and updated fuel transfer systems to accommodate the Raptor 3 engines, which require more efficient fuel flow. Additionally, the water deluge system has been redesigned to support the new flame trench configuration. Because the twin flame buckets demand a much greater flow of water than the previous steel plate cooling system used at Pad 1, SpaceX has had to install higher capacity pumps and storage tanks to ensure sufficient cooling during liftoff. All of these systems will be put to the test during Flight 12, making it a crucial trial for Starbase's long-term operations. Now, let us turn to the rocket itself, where the most significant changes reside. The centerpiece of this upgrade is the new Raptor 3 engine, which will power both stages of Starship for the first time. With 33 Raptor 3 engines firing at liftoff, the booster will generate more than 9,000 tons of thrust, over 2.7 times greater than NASA's Saturn V rocket. This level of power will make Flight 12 one of the most spectacular launches in history. However, Raptor 3 is not just about raw power. It's been redesigned from the ground up to improve reliability and efficiency. The engine contains fewer parts, simplified plumbing, and improved ignition systems, all of which reduce operational risks and maintenance time. SpaceX has emphasized that the new design also improves manufacturing efficiency, allowing the company to scale production and replacement more easily. During Flight 12, these engines will be under close observation. Their performance will determine whether SpaceX can move forward with future milestones such as payload delivery, orbital refueling, and eventually catching both stages mid-air. Any significant engine issues could slow that progress, so reliability will be the key focus of this test. After liftoff, Starship will proceed through ascent and enter the hot staging phase, a process that has been upgraded. Unlike the earlier V2 flights, where the hot staging ring was a separate structure placed between the two stages, the new configuration integrates the system directly into the top of the booster. This means the hot staging system is now part of the first stage itself, simplifying assembly and reducing pre-flight preparations. Once the upper stage ignites, the integrated ring will separate cleanly from the booster, minimizing debris and improving efficiency. In fact, the hot staging section is no longer discarded because its mass has been greatly reduced compared to the previous design, which is clearly visible even to the naked eye. The new structure is simpler and more efficient, allowing for better dissipation of heat and pressure during the separation process. This improvement not only enhances performance but also strengthens the overall durability of the system. As a result, the new hot staging design will play an important role in SpaceX and Musk's secret plan for Flight 12. While it remains an experimental feature, its likelihood of success is expected to be much higher than that of the engines. During the booster's descent, another major upgrade will come into play: the grid fins. These components have undergone significant refinements in shape, number, positioning, size, and weight. The purpose of these upgrades is to improve aerodynamic control and increase the fin's long-term durability. The new grid fins will work alongside the engines to stabilize and steer the booster during its return, while also contributing to a smoother deceleration process. Most notably, these upgraded fins will integrate catching points directly into their design, marking a key step towards SpaceX's long-term goal of catching and reusing the entire booster. Flight 12 will serve as an early test for this integrated system, evaluating how well the fins perform in both guidance and catching readiness. Meanwhile, the Starship upper stage, known simply as the ship, will continue its mission beyond Earth's atmosphere. One of its main objectives will be payload deployment. While details remain limited, the V3 version of the dispenser is expected to include several upgrades, allowing the system to handle and deploy real payloads more effectively than before. This development marks another step closer to full operational missions, where Starship will eventually deliver satellites and cargo to orbit. The ship will also perform a relight test of its engines in space, showcasing the capabilities of the newly developed Raptor. Version number 3. These engines are designed to deliver stronger performance and improved reliability even in the harsh environment of space. However, perhaps the most critical upgrade for the ship is its heat shield. Although SpaceX has not revealed the full details, the heat shield for Starship V3 is believed to represent one of the largest system overhauls to date. Improvements likely include stronger tile materials, more secure attachment methods, refined placement, and enhanced cooling systems. These changes aim to prevent issues that have occurred in past flights, such as tile loss, cracks, or leaks. The new design should better protect the vehicle during re-entry, particularly against intense heating and oxidation. Of special interest are the heat shield tiles located on the aft flaps. This section has historically been one of the most vulnerable parts of the vehicle, often experiencing excessive heat and mechanical stress during descent. Strengthening this area will be crucial for maintaining stability and ensuring that the ship can maneuver properly in the atmosphere. By solving these problems, SpaceX can improve both the safety and precision of re-entry, paving the way for more advanced recovery methods in future flights. Much like the upgrades made to the ground systems and the Super Heavy booster, the changes applied to the ship remain experimental. However, the expectation is that they will perform reliably enough to support future milestones. For example, the new payload deployment system must function correctly to demonstrate readiness for commercial missions, while the heat shield must perform flawlessly to enable a safe and consistent return. Both of these improvements are essential to moving closer to SpaceX's ambitious goal of a two-stage catch and full vehicle reuse. If these upgrades succeed, Flight 12 could represent one of the most important turning points in Starship's journey. Every improvement from the hot staging system to the grid fins and heat shield will serve as a building block toward a fully reusable and highly efficient launch system. So which of these upgrades are you most eager to see in action? Let me know in the comments, and make sure to follow every phase of Flight 12 closely because this test could redefine what's possible in spaceflight. At this stage, SpaceX has an enormous amount of work ahead to make Flight 12 a reality. If the mission is to take place before the end of the year, that leaves less than 2 months to prepare, which is an incredibly tight schedule even by SpaceX's ambitious standards. Right now, both the rocket and the launch infrastructure remain incomplete. The vehicle itself is still undergoing assembly, while the new Launchpad has not yet finished installation. This means that the crucial testing sequence, which includes cryogenic tests, tank pressure trials, and static fire runs, has not even begun. For everything to align on time, the SpaceX team will need to accelerate progress across every system involved. Super Heavy, the powerful first stage, is nearing completion and could be ready for testing in early November. However, the upper stage, known as the ship, has only just entered its stacking phase. For SpaceX to meet its goal, Super Heavy should complete its testing by mid-December, while the ship must finish its own series of tests by late December. Only then can both stages be integrated and prepared for a launch attempt in the final days of the year. In parallel, the supporting infrastructure must also come online quickly. The test systems need to be reactivated, and the new Launchpad must undergo thorough verification to ensure it can safely handle the immense power of the upgraded Raptor 3 engines and the new Flame Trench system. All of these steps point to a critical buildup toward one of the most important Starship missions yet. Flight 12 will mark the first launch of the V3 version, a milestone that could shape the future of SpaceX's deep space ambitions. However, this flight faces a unique dual challenge. It must test an array of new upgrades while still demonstrating enough success to keep the program on track. Balancing experimentation and reliability within a single mission is no easy task. We are standing at the edge of another historic step in space exploration. The countdown to Starship Flight 12 has begun. Are you ready to witness what could be the most ambitious and transformative launch in SpaceX's history? V2 to V3. That transformation is now in full swing at Starbase. The launch vehicle itself is the most visible sign of this evolution, but significant changes are also taking place at the Launchpad. Launchpad 1 is undergoing major upgrades and redesigns as the old configuration can no longer meet the demands of the new generation of Starship. These improvements mark a bold step forward for SpaceX and promise an exciting return to flight next year, or perhaps even sooner than expected. So how exactly is SpaceX upgrading Launchpad 1? We have shared countless memories with the original design of Launchpad 1. From the iconic six-legged OLM to the inverted water deluge system, and of course the massive chopstick arms, each component has played a crucial role in SpaceX's Starship journey. Over the course of 11 official launches and many smaller tests, this pad has stood as a witness to the evolution of Starship from its earliest prototypes to its most recent successes. It has been a symbol of innovation, resilience, and relentless progress. However, as SpaceX transitions from the Starship V2 era to the more advanced V3 generation, the old systems are no longer sufficient. The company has entered a new phase of development that demands major upgrades across every part of launch infrastructure. The transformation of Pad 1 is not just an update, it's a complete reimagining designed to meet the demands of the next generation of Starship vehicles. In fact, this process began even before the 11th flight. One of the earliest signs of change was the removal of the damper system that supported landings from the chopstick arms. This signaled that SpaceX was preparing for a comprehensive redesign of the arm system itself. Shortly after that, activity at the pad intensified. Workers began venting the CO2 tanks from the deluge system area and depressurizing parts of the launch tower and the quick disconnect system. These steps were likely taken to ensure a safe environment for workers to begin modifications on critical hardware. Once that preparation phase was complete, the chopsticks became the main focus of attention. The pusher system, which had previously been used to assist in vehicle alignment and stabilization, was removed. Soon after, the lift pins for the Starship vehicle were detached, indicating that the entire lifting mechanism was being reworked. Another major update came when observers noticed that the cable connected to the traveling block at the base of the chopsticks had disappeared. This cable played a key role in raising and lowering the arms, so its removal meant that the chopsticks would remain stationary while undergoing significant modifications. Changes were not limited to the tower. The surrounding support systems at the pad were also being transformed. The berm near Pad 1, a protective mound used for safety and containment, was demolished. This demolition likely aimed to create open space for easier movement of heavy equipment and to make room for future expansion of the tank farm area. Meanwhile, work continued directly at the tank farm. One of the most notable updates was the removal of the liquid oxygen pump. Since this pump is a vital component of the fueling system, its removal suggests that no major tank farm operations or testing will occur for some time. This pause in activity indicates that SpaceX plans to overhaul the tank farm completely, possibly adding larger tanks or rearranging the layouts for better efficiency. It's expected that the liquid methane pump will soon follow the same path, further preparing the site for a comprehensive upgrade. Of course, these pumps will not simply be scrapped. They are likely being refurbished or replaced with more advanced versions. Once Pad 1's tank farm upgrades are complete, these components could be reinstalled or even shipped to SpaceX's facilities in Florida to support parallel operations there. All of these efforts mark only the beginning of Pad 1's transformation. In the months ahead, far larger construction projects will unfold. One of the first major changes will involve shortening the length of the Chopstick arms, similar to those already built at Pad 2. The new, more compact arms will reduce overall mass, allowing for greater flexibility and precision in operation. New systems will also be introduced, including improved catching mechanisms, a redesigned landing rail, and updated dampers. These components will be customized to fit the next-generation Starship and booster configurations. Early design information suggests that the new chopsticks at Pad 1 will primarily focus on supporting the booster, while the catching system will be integrated directly into the grid fins of the booster itself. In other words, the new chopsticks will be tailored to match the structural design of the upgraded Super Heavy, creating a seamless interaction between rocket and pad. Once the structural work is complete, new cables will be installed to restore the lifting functionality of the chopsticks. Testing will then resume, beginning with lifting trials and progressing toward full operational checks. Beneath the launch tower, an even more dramatic transformation will take place. The cranes will soon move in to begin dismantling the old OLM. The process will start with the removal of internal components such as the clamp arms, tubing, and interface panels of the BQD system. Once the smaller parts are cleared, workers will move on to the larger structures, the BQD frame, the OLM table, and finally the support legs. After these components are removed, the large steel water-cooled plate will be lifted away, marking the end of the old mounts era. Following the teardown, the surrounding area will be cleared and prepared for excavation. The ground will be reshaped to accommodate a new flame trench, a critical addition that will help direct exhaust and heat away from the pad during launches. Once the trench has been excavated, concrete will be poured to create a stable foundation, which will then be reinforced with steel plates and an additional layer of concrete for strength. After the foundation is secured, engineers will begin installing the flame deflector buckets and exhaust pipes, which will be anchored in place with concrete. Around the trench, taller support structures will rise to form the base of the new OLM platform. Alongside this, a new BQD system will be constructed, fully integrated with updated water, fuel, and electrical systems. Meanwhile, the tank farm will continue to expand and modernize. Larger tanks may replace smaller ones, and the additional space created by removing the berm will likely be used to install new piping, control systems, and possibly cryogenic storage units to support higher launch cadence. It's safe to say that Pad 1's transformation is now well underway. Each day brings visible signs of progress, from dismantling legacy systems to installing new foundations that will support the future of Starship launches. As these major upgrades continue, the excitement surrounding Starbase is building once again. So what upgrade are you most excited to see at Pad 1? Share your thoughts in the comments, like the video, and subscribe to the channel to stay updated on SpaceX's extraordinary journey of innovation and discovery. Among the greatest challenges ahead lies the development and testing of orbital refilling, a feat that demands pinpoint navigation, intricate fluid transfer, and seamless coordination between spacecraft. Many consider it Starship's most formidable obstacle, with skeptics doubting it can be perfected in time. Yet Musk and Gwynne Shotwell remain steadfast in their confidence. likening the challenge to Dragon's flawless ISS dockings, a precision SpaceX has already mastered. If that same excellence carries over, orbital refilling could become a reality as soon as next year. Meanwhile, SpaceX continues refining Starship HLS's interior for transport and habitation, ensuring safety, comfort, and flexibility. Musk has even suggested turning landed starships into lunar habitats, a bold step toward permanence. The coming year will be decisive. Every flight, every milestone, will determine whether Starship can rise to NASA's expectations and secure humanity's lasting foothold beyond Earth. These upgrades extend far beyond Pad 1. They are part of a sweeping transformation across all future Starship launch sites. Leading the charge is Pad 2 at Starbase, but its fiercest competitor in this race for readiness is none other than Launch Complex 39A at Cape Canaveral. Like Pad 1, LC-39A's evolution builds upon the foundation of proven infrastructure, giving SpaceX a valuable head start. No need to raise a new tower from scratch when history itself provides the base for the future. At present, LC-39A has already made significant progress. The flame trench has been fully excavated, and the flame buckets and OLM are currently being assembled. With work proceeding at this pace, LC-39A remains ahead of Pad 1 in overall progress. If everything continues smoothly, the construction could wrap up by the middle of next year. Testing would follow soon after, paving the way for operational readiness by the end of the year. Perfect timing for critical missions, such as the uncrewed lunar landing demonstration. So the question now is, which pad will be ready first? Will Pad 1 make an unexpected comeback, or will LC-39A solidify its lead? Beyond these three pads, Pad 1, 2, and LC-39A, SpaceX is also preparing to expand even further. The company recently took over Space Launch Complex 37, or SLC-37 for short, where 2 new Starship pads are planned. These will be constructed entirely from scratch, similar to how Pad 2 was built, which means their completion will take more time. Current projections suggest that we may have to wait until at least 2027 before SLC-37 becomes fully operational. Altogether, this expansion paints an extraordinary picture of SpaceX's future. Some projections suggest up to 25 annual launches from Starbase, 44 from LC-39A, and an astonishing 76 from SLC-37 once both pads there are active. These numbers showcase the massive potential of the Starship program and its role in reshaping humanity's access to space. A thrilling future is indeed on the horizon, and with every upgrade to the launch pads, that vision edges ever closer to reality. Each pad tells a story, a living reflection of the Starship program's relentless evolution. Among them, Pad 1 at Starbase stands as the most iconic symbol of that transformation. Once the cradle of Starship's earliest trials, it has now evolved into a far more advanced and enduring system, rebuilt not just for launches, but for the future of humanity's journey beyond Earth. From this foundation, the upgrade process will continue to expand across other launch sites, setting the stage for a vast and powerful network of Starship launch pads within the next 1 to 2 years. Each pad will embody a new step in SpaceX's technological progression, enabling faster, safer, and more frequent launches than ever before. For now, as the larger structures at Pad 1 remain standing in their familiar form, it's the perfect time to look back and appreciate their legacy. These structures carried SpaceX through its early challenges, supported the first monumental flights, and helped turn ambitious visions into tangible achievements. Soon they will give way to a new generation of infrastructure, marking yet another bold chapter in Starship's relentless journey forward. How dramatic this has become. A former NASA admin who once selected SpaceX's Starship for Artemis is now speaking out against it, igniting debate across the aerospace world. SpaceX, however, remains confident, backed by steady progress in testing and hardware development. What caused this sudden tension, and what does it mean for Artemis and Starship's future? Meanwhile, Blue Origin's New Glenn has completed testing for its second launch attempt, adding even more intrigue to the growing commercial space race. A few years ago, NASA made headlines when it chose SpaceX's Starship to serve as the HLS for the Artemis program. At the time, NASA was led by Administrator Jim Bridenstine, who strongly supported the decision, calling it a bold step toward returning humanity to the moon. Yet now, in a surprising turn of events, the same man who once placed his trust in Starship has begun speaking out against it. This shift in tone became evident during the American Astronomical Society's Von Braun Space Exploration Symposium on the 29th of October. Bridenstine, along with another former NASA administrator, Charlie Bolden, participated in a panel discussion about the current structure of the Artemis program. Much of the conversation centered on SpaceX's Starship HLS, and the two former administrators raised concerns about whether the program, as it currently stands, can deliver on its timeline. Bridenstine voiced skepticism that the U.S. could return astronauts to the lunar surface before China's first crewed moon mission, warning that time was running out. The probability of beating China approaches zero rapidly, he said. We have to do something different. He went on to suggest that if the U.S. truly intends to land humans on the moon before China, NASA should take an approach modeled after the Defense Production Act, a wartime measure used to accelerate industrial output. If the goal is to beat China to the moon, he said, we need to have a program that is, dare I say, a Defense Production Act kind of program. We're going all in to build a landing system as quickly as possible with a small team that has authority, maybe authority put together by an executive order from the President of the U.S. That this is a national security imperative that we're going to beat China to the moon. Bridenstine also commented directly on Starship's design and development, acknowledging its long-term promise but expressing doubts about its readiness. Starship is a tremendously important vehicle for the future, he said. It's going to deliver large mass to low Earth orbit for a long time, and it's going to drive down costs and increase access. But if you need a moon lander, it's going to take time. He also voiced support for acting NASA Administrator Sean Duffy's recent decision to open competition for the Artemis 3 mission, suggesting that a new lander design might be necessary to accelerate the schedule. Charlie Bolden, who served as NASA Administrator during the Obama administration, echoed Bridenstine's concerns. He pointed to structural issues within the Artemis program and the need for better coordination and time management. Bolden ended his remarks by saying he believes it is possible for NASA to return astronauts to the moon by the end of the current presidential term, if, that is, changes are made quickly. Both Bridenstine and Bolden also referenced Blue Origin's Blue Moon lander as a potential alternative or complementary solution to help NASA meet its lunar goals sooner. Their comments, intentionally or not, seemed to question SpaceX's position at the center of the Artemis program and reignited the debate over whether Starship is progressing fast enough. SpaceX wasted no time in responding. SpaceX defended its record and challenged Bridenstine's recent remarks. Mr. Bridenstine's current campaign against Starship is either misguided or intentionally misleading, the company stated. SpaceX was selected to design and develop a human landing system for Artemis, along with Blue Origin and Dynetics, during Mr. Bridenstine's tenure as NASA administrator. The company further clarified how it earned its selection. Starship was then chosen by NASA for the Artemis 3 mission through fair and open competition, after being identified as the best and lowest risk technical option and the lowest price by a wide margin by the civil servant team appointed to lead the agency's exploration mission by Mr. Bridenstine himself. SpaceX also reminded the public that the decision was repeatedly reaffirmed, even after protests and lawsuits from competing companies delayed the program's progress. The decision to select Starship was repeatedly confirmed after protest and litigation from the companies not selected, which delayed the start of work on the contract for many months, the statement read. Finally, SpaceX concluded with a sharp rebuke. Mr. Bridenstine's recent musings promoting a new landing system, going so far as to invoke the Defense Production Act, are being misreported as though they were the unbiased thoughts of a former NASA administrator. They are not. SpaceX's response did more than just defend its credibility. It was also a reaffirmation of Starship's progress and potential. Starship continues to simultaneously be the fastest path to returning humans to the surface of the moon and a core enabler of the Artemis program's goal to establish a permanent, sustainable presence on the lunar surface, the company stated. The latest batch of Starship HLS images has taken the aerospace community by storm, offering the most detailed look yet at the vehicle that SpaceX plans to use to return astronauts to the moon. These images are not just beautiful, they are historic. For years, enthusiasts and experts alike have speculated about what the HLS variant of Starship would look like, and now, at last, those details are coming into focus. The first two images show the Starship HLS full stack on the Launchpad, an awe-inspiring sight that many have been eagerly anticipating. At first glance, it might appear similar to a standard Starship launch configuration, but closer inspection reveals several critical design differences unique to the lunar version. One of the most noticeable changes is in the forward section of the spacecraft. Instead of the complex array of features seen on previous prototypes, this version has a clean, streamlined appearance marked by a single thin black line. That line likely marks the separation between the fuel tank and the crew section. In the updated design, the traditional Starship cargo door is gone, replaced by a square hatch designed specifically to deploy an elevator system. This elevator will be used by astronauts to descend from the crew cabin to the lunar surface. Just beside this hatch, there is a row of small windows, likely intended for observation, giving the spacecraft a distinctly human touch amid its immense scale. These details hint at Starship HLS's dual purpose, not just a machine for exploration, but also a temporary home for astronauts working on the moon. Moving down to the base, one of the most talked about aspects of the new images is the addition of landing legs, a practical solution for early missions where infrastructure on the moon is limited. The legs themselves appear to fold out from the base, painted black and designed with a mechanism that resembles the Falcon 9's boosters, though inverted in deployment direction. This design ensures that Starship can land securely on the uneven lunar surface. Inside, SpaceX's new renderings and design updates reveal an interior far more refined and spacious than earlier concepts. The crew cabin now spans multiple levels, with stairways connecting them in the center for easy movement. The most striking feature is a high balcony overlooking large viewing windows, perfect for monitoring lunar operations or simply observing the majestic lunar landscape. The layout looks clean, organized, and optimized for both functionality and comfort. Compared to earlier leaks, this configuration presents a more realistic and livable environment for astronauts who may spend extended time on the moon. According to SpaceX's latest technical documentation, the company continues to emphasize Starship's scale and capability. The HLS version boasts a habitable volume of 600 cubic meters, which is roughly two-thirds that of the entire International Space Station. It also features two airlocks, each with 13 cubic meters of volume, providing double the available space of the Apollo lunar module. This enormous volume allows Starship HLS to carry both a large crew and substantial cargo, with a capacity of up to 100 metric tons to the lunar surface. No lander in history, past or present, has ever come close to such performance. SpaceX reaffirmed the cost advantages of its fully reusable Starship system, emphasizing that it continues to self-fund much of the infrastructure to achieve rapid reuse at minimal cost. The rocket's simplicity and scalability are designed to cut launch prices dramatically, enabling frequent lunar missions and supporting NASA's long-term goal of a sustained human presence on the moon. The company reported 49 milestones completed under the HLS program, including life support testing, environmental control demonstrations, Orion integration, and landing leg trials. The HLS capsule itself has been built, equipped with core systems, and is now undergoing final integration. Next, SpaceX plans to test in-space refueling, a key step for lunar operations, and debut the Starship V3 with upgraded Raptor 3 engines, major milestones set for the coming year as Artemis deadlines approach. These updates send a clear message. SpaceX remains confident in Starship HLS and intent on proving steady progress despite criticism and internal NASA debates. Every milestone reinforces one belief: Starship will return humans to the moon. Do you think SpaceX will achieve this ambitious goal on schedule? Share your thoughts in the comment section down below, and don't forget to like and subscribe to Great SpaceX for more updates on humanity's journey to the stars. In the meantime, while SpaceX continues to capture global attention, its strongest competitor, Blue Origin, has been making remarkable progress of its own. The company's massive orbital rocket, New Glenn, is finally nearing its long-awaited debut launch, expected between November 9th and the 11th. A major milestone came on the 30th of October when Blue Origin successfully conducted a static fire test at Cape Canaveral's LC-36. For 38 seconds, the rocket's 7 BE-4 engines roared to life, producing an incredible 1,700 tons of thrust, a powerful step forward on the path to launch. Both the company's founder Jeff Bezos and CEO Dave Limp celebrated the test, noting that engineers extended the burn to simulate landing conditions, shutting down engines in sequence to study fluid dynamics during throttle transitions, which is crucial for booster recovery. Blue Origin confirmed all engines performed nominally, signaling that the once troubled BE-4s are finally operating reliably. The test came amid earlier reports of upper stage issues, but its success has restored confidence in meeting the early November launch target. Afterward, the booster was returned for inspection while integration continued for NASA's ESCAPADE mission, which will study Mars's magnetosphere. The maiden flight aims to both deploy ESCAPADE and land the first stage booster on an Atlantic drone ship. Success would mark Blue Origin's first orbital victory, prove New Glenn's reusability, and strengthen its position against SpaceX. It could also earn long-sought military certification, validating years of effort and investment. After years of delay, New Glenn is finally ready to fly, poised to redefine Blue Origin's future and reshape competition in the new space age. Simplification has always defined SpaceX's strategy, and it may once again change everything. Facing skepticism over its HLS, SpaceX is doubling down on efficiency, refining its lunar design to move faster and cut costs without sacrificing reliability. This streamlined approach could accelerate Starship's development, reduce risks, and give SpaceX a decisive edge in the Artemis race. If it succeeds, it won't just transform lunar exploration, it could reshape humanity's path to Mars and beyond. The past few weeks have been some of the most challenging yet defining moments for SpaceX's Lunar Starship program. The company has faced a storm of criticism, and much of it comes from both current and former NASA officials who question Starship's pace of progress and its technical complexity. These concerns have reignited discussions about whether SpaceX can meet the demanding timeline for NASA's Artemis missions and deliver on its bold promise to return humans to the moon. Yet, as history has shown, SpaceX rarely shies away from adversity. This time, SpaceX's response centers on a single guiding principle that has defined many of its greatest successes: simplification. In a recent update, SpaceX made its stance clear. Since the contract was awarded, we have been consistently responsive to NASA as requirements for Artemis 3 have changed and have shared ideas on how to simplify the mission to align with national priorities. In response to the latest calls, we've shared and are formally assessing a simplified mission architecture and concept of operations that we believe will result in a faster return to the moon while simultaneously improving crew safety. While the company did not specify exactly what these simplifications entail, the tone of their message radiates confidence. SpaceX also reaffirmed that Starship continues to simultaneously be the fastest path to returning humans to the surface of the moon and a core enabler of the Artemis program's goal of establishing a permanent, sustainable presence on the surface. This statement makes one thing clear: SpaceX believes its approach is superior to any other solution currently on the table, and this announcement comes at a crucial moment, right as NASA has decided to reopen competition for Artemis 3. SpaceX appears determined not just to stay in the race, but to redefine it entirely. So how exactly will SpaceX simplify its lunar mission? The company emphasized a streamlined mission architecture and concept of operations. That phrasing suggests potential adjustments in how Starship will interact with NASA's systems, including the Orion spacecraft, or perhaps a complete rethinking of the steps required to reach the lunar surface. One possible scenario is that SpaceX may opt for a more direct approach, having Starship transport astronauts directly from Earth to the moon and back, removing the need to dock with NASA's Orion capsule in lunar orbit. This would eliminate the entire layer of complexity, cost, and risk. It could also allow SpaceX to operate independently of the slower, more bureaucratic systems NASA has been developing for over a decade, such as the Space Launch System. By simplifying the process, SpaceX could move faster and maintain full control over the mission's schedule and execution. Such a change would not only speed up operations, but also highlight a stark contrast between SpaceX's agile, iterative model and NASA's traditional, cautious approach. It'd be a bold statement that innovation, not bureaucracy, leads the way forward in space exploration. The simplification becomes even more apparent when examining the latest Starship HLS design renderings. Compared to previous iterations, the new model embodies a cleaner, more efficient approach. Earlier versions featured complex folding leg structures and an intricate arrangement of black glass panels around the crew section. While visually striking, these designs introduced challenges in manufacturing, installation, and structural stability. The second iteration, which used a fixed leg design, solved some of those problems but created new ones, such as limited flexibility for stacking and landing, and cumbersome solar panel installations. The newest design resolves these issues elegantly. First, the crew compartment now follows a more uniform structure. The number of windows has been reduced, maintaining just enough for observation while reinforcing structural integrity and improving safety. Fewer windows also mean greater thermal protection and privacy for the crew. It's a thoughtful balance between practicality and comfort, key elements for long-duration missions. Next, the crew access door has been simplified to align perfectly with the elevator system used for lunar surface deployment. The door's design now mirrors the dimensions of the airlock, which supports efficient crew movement and equipment transfers. This refined layout not only enhances safety and functionality, but also hints at Starship's future potential. When viewed horizontally, this same doorway could serve as an entry point for a lunar base, suggesting how the HLS variant might evolve into a permanent moon habitat one day. Perhaps the most noticeable improvement lies in the landing legs. SpaceX has adopted a folding mechanism reminiscent of Falcon 9's proven design, but adapted for the lunar environment. The legs deploy from the lower section of the vehicle rather than the upper portion, allowing Starship to remain closer to the ground for stability on uneven terrain. It's possible these legs also include a spring or shock-absorbing system to cushion landings on rugged lunar surfaces. This modification represents both simplicity and smart engineering, reducing complexity while enhancing reliability. Inside, the refinements are just as impressive. Earlier concept art depicted a two-floor configuration, which many critics argued was too compact for extended crew operations. The new design reveals a far more open and functional interior, complete with additional workspace, living quarters, and even a balcony-style observation area offering panoramic views through the side windows. The staircase, positioned centrally, provides smoother access between floors, promoting better movement and efficiency for astronauts during operations. Together, these changes demonstrate how simplification in design can lead to significant practical gains. This renewed focus on simplicity could allow the company to achieve what once seemed impossible: a faster, safer, and more sustainable path to the moon. It would not only validate SpaceX's engineering philosophy, but also challenge NASA to rethink how human spaceflight missions are designed in the modern era. So, what do you think of SpaceX's simplification strategy? Could this approach truly put humans back on the moon sooner than expected? If you believe so, let me know with a "let's do it" down in the comments below. And don't forget to like the video and subscribe to our channel for more updates on SpaceX's journey to the moon and beyond. Simplicity has always been the cornerstone of SpaceX's engineering philosophy, and now it may be the secret to winning the race to the moon. The company's recent announcements make one thing unmistakably evident: this streamlined approach is not just about elegant design, but about achieving greater speed, efficiency, and reliability. SpaceX has emphasized that its simplified mission plan is built around one goal: reaching the lunar surface faster than any other contender, even those with the most optimistic timelines. At the moment, NASA's Artemis 3 mission is officially scheduled for mid to late 2027. If NASA proceeds with opening a new contract competition for the mission, as has recently been suggested, that timeline is unlikely to accelerate. However, SpaceX seems seems determined to move ahead of schedule to meet the demands of the Artemis program and maintain its lead. SpaceX may aim to complete its own milestones as early as the first half of 2027. But the real question is, can they actually do it? Based on SpaceX's most recent progress report, the answer appears increasingly promising. The company revealed that it has already completed 49 major milestones related to the Starship HLS program. Each successful test brings SpaceX one step closer to proving that Starship is not just a concept, but a fully capable lunar lander ready for crewed missions. These achievements have built growing confidence within the aerospace community that SpaceX may indeed return astronauts to the moon on schedule, or perhaps even earlier than NASA's official target. Still, major work remains before that vision can become a reality. Among the most critical tasks ahead is the completion and testing of SpaceX's in-orbit refilling system, a cornerstone of Starship's lunar mission architecture. According to the company, several refilling demonstrations are planned for next year. These are expected to begin around mid-2026, following the first missions that will validate Starship's upgraded V3 architecture. Those initial V3 flights will demonstrate the rocket's ability to reach orbit, deploy payloads, and achieve successful landings for both stages. Key steps before the complex refilling operations can begin. Around the same period, the first dedicated Starship HLS prototypes are expected to emerge. SpaceX will likely build at least 2 units, one for the uncrewed lunar landing demonstration and another for testing the refilling process under real mission conditions. The uncrewed demonstration will serve as a crucial proof of concept, showing that Starship can safely descend and land on the moon's surface. The second prototype will likely test in-orbit fuel transfer and other systems essential for crewed flight readiness. After these tests, the remaining flight-ready Starship will be reserved for the first crewed lunar mission under Artemis 3. If SpaceX can maintain its momentum and execute its simplified mission plan effectively, the company could achieve what was once seemed unthinkable: landing astronauts on the moon within the current schedule or even ahead of it. NASA's latest decision has placed the Artemis program under an even brighter spotlight, and with that, controversy is sure to follow. For months, both current and former NASA officials have voiced concerns over the pace of SpaceX's Starship development, sparking discussions about reopening the competition for the Artemis 3 lunar lander, potentially giving Blue Origin's Blue Moon another chance to challenge SpaceX's lead. Yet, if SpaceX wins again, it would reveal a contradiction, NASA doubting the very partner it continues to choose. And when comparing progress, the result seems inevitable. SpaceX's transparency and steady advancements far outpace competitors still struggling to catch up. Blue Moon, while promising, relies on legacy design and an unproven launch vehicle. New Glenn has flown only once, and even with another flight ahead, scaling it for Artemis remains uncertain. Without it, NASA would need costly, slow alternatives like SLS or Vulcan, neither capable of matching the reusability or affordability of Starship's integrated system. SpaceX's simplified architecture offers what NASA needs most: speed, flexibility, and the capacity to keep the US ahead in the new space race. I think it's safe to say that surprise is the best emotion to convey our feeling when looking at the current state of Starship HLS. NASA's recent decision by Sean Duffy has reignited debate and intensified pressure on SpaceX to show real progress. Yet SpaceX has responded impressively, revealing major updates that surprised even close observers. These moves suggest the company is advancing faster and more strategically than expected, potentially reshaping how NASA's decision is viewed. If SpaceX succeeds, what once seemed a setback could prove a bold, calculated step toward humanity's next lunar landing using a fully reusable spacecraft. So how far has SpaceX come, and what key steps are shaping the future of lunar exploration? We're now approaching the end of 2025, and time is moving fast. That means there's only about 1 year left before SpaceX must perform the uncrewed lunar landing demonstration, and less than 2 years before the highly anticipated Artemis 3 mission. where astronauts are expected to step onto the moon using Starship HLS. This is not just a milestone for SpaceX, but also a defining moment for the US in its renewed race to the moon against China. Given this short timeline, this is precisely the moment when the first fully developed prototype of Starship HLS should begin to appear. The world is watching closely not only to see SpaceX's next steps, but also to gauge America's confidence in maintaining leadership in this new era of lunar exploration. However, SpaceX's progress has recently faced increased scrutiny. Even NASA, the agency that entrusted SpaceX with the Artemis HLS contract, has expressed concern over the company's pace of development. This concern led to NASA's recent controversial decision that has stirred discussion across the aerospace community. In response, SpaceX seems determined to prove that its progress is both real and significant. Concrete steps have begun to surface, with new signs pointing directly to ongoing work on the Starship HLS prototype. One particularly intriguing moment occurred on the 23rd of this month when a strange ring section was moved out of SpaceX's Star Factory. Observers immediately noticed that it had an unusual shape. The ring appeared to taper slightly toward the top, strongly suggesting that it might be part of a Starship nose cone. Based on its movement toward the Sanchez site, many assumed it was being scrapped, yet the mystery deepened when people noticed something peculiar about its surface. The ring featured a series of evenly spaced square cutouts that look remarkably deliberate, as if each had been measured and laser cut from the stainless steel structure. This was not a typical discarded section. It was the strangest ring seen at the Star Factory so far, and the precision of the cuts raised an important question. Why would SpaceX design a ring section like this? For many optimistic observers, the answer was clear. They believed this was not scrap metal, but part of a special crude prototype, a possible mock-up for Starship HLS itself. The square holes might represent the windows of the crew compartment. This theory aligns well with the previous 3D renders of Starship's crewed versions, which have shown several large windows designed to give astronauts a broad and inspiring view of space and the lunar surface. If this theory is correct, the ring could have been used for early structural tests inside the Star Factory. Perhaps SpaceX engineers were evaluating how the addition of multiple windows would affect the strength and stability of the spacecraft's hull. Supporting this idea, each square cutout in the ring appears to have one or two vertical metal bars welded into place. These bars may have been used to simulate the presence of window frames or reinforcements during the pressure tests. This type of testing is not unheard of. Companies like Sierra Space perform similar tests on their inflatable habitat modules to ensure that windows can withstand the stress of pressurization. In SpaceX's case, such tests would be even more critical because Starship is built entirely from stainless steel, a fixed, rigid material rather than a flexible one. Testing window structures would help SpaceX determine whether the hull deforms, cracks, or weakens after being modified for crew access and visibility. There's also the possibility that glass panels or mock windows were temporarily installed in the section to evaluate how they would perform under simulated pressure and thermal conditions. Of course, not everyone agrees with this optimistic interpretation. Many argue that the ring is nothing more than a discarded section of a prototype that failed to meet structural requirements. Critics point out that the cutouts on the ring appear to be arranged randomly, while the actual Starship HLS windows would likely be positioned symmetrically in neat rows. There are also inconsistencies with the known design of Starship HLS. According to leaked diagrams, the crew compartment features two main levels and therefore two distinct rows of windows. In contrast, the mysterious ring section had cutouts spread across several uneven levels. Additionally, the windows on HLS are expected to appear only on the leeward side of the spacecraft, facing away from the heat and stress of re-entry, while the other side remains solid for better structural integrity. The cutouts on the ring, however, seemed to cover all sides. Finally, the square holes themselves appear quite large compared to the smaller, more practical window designs seen in Starship renders. These factors suggest the ring might not be part of a true Starship HLS structure after all. Still, despite these doubts, the discovery has reignited excitement among Starship watchers. Whether it's a test article or a discarded section, Its unusual design and timing point to active work on something new, and that something could very well be tied to SpaceX's preparations for the moon. At this point, we can only wait for confirmation from SpaceX. So far, the company has not made any official statements about the purpose of this ring, leaving room for speculation and anticipation. But one thing is certain, every small movement at Starbase now carries great weight, as each piece could mark another step toward humanity's return to the lunar surface. So, what do you think? Is this mysterious ring section connected to Starship HLS? Let me know your thoughts in the comment section down below. However, no one can measure SpaceX's readiness for Artemis 3 based on a single ring section or one mysterious prototype. True confidence must come from the entire ecosystem being built to support the lunar architecture, and that ecosystem depends not only on the Starship HLS itself, but on something equally vital, the orbital refilling system. Yet this system remains one of the greatest technical challenges SpaceX has ever attempted. It demands precision docking, flawless fluid transfer between spacecraft, and an unprecedented level of coordination between multiple starships flying in succession. No one has ever attempted such a feat before. That's why the recent movement of Ship 39, the first Ship V3 prototype, has generated such intense speculation and excitement. Sharp-eyed observers noticed something new on its payload section: two strange metallic pins located just beneath the payload door. They stand out unlike anything seen on earlier Starship designs, and their purpose seems clear. These could very well be the first visible signs of SpaceX's orbital refilling hardware. For two starships to connect and transfer propellant in orbit, they need robust mechanical and fluid interfaces. Those twin pins may serve as anchor points where specialized pipes will connect to fuel lines, allowing methane and oxygen to flow from one starship to another. At the ends of these pipes, additional couplings would handle the transfer and equalization of pressure between the two vehicles. The appearance of such hardware on S-39 marks an important milestone. It suggests SpaceX is no longer just theorizing about refilling, they're building and testing it. Even if these pins won't be used during the early V3 missions, their installation is a crucial step. SpaceX can now evaluate how such components endure the stresses of launch, ascent, and re-entry. Any deformation, vibration, or thermal issues discovered in these early flights will inform vital design refinements before the first real refilling test occurs. If earlier sightings, like the mysterious ring section, left fans uncertain about progress on Starship HLS, this tangible step forward in refilling design leaves far less doubt. The evidence points to SpaceX actively preparing the tools and systems that will make lunar flight possible. Still, it's worth noting that refilling won't happen right away. The first V3 missions will focus on validating new latching mechanisms, structural upgrades, and achieving reliable stage recovery using the Megazilla arms. These flights will also push toward the goal of deploying payloads to orbit with both stages successfully returning for reuse. Refilling tests, according to internal timelines and community analysis, may begin around Flight 16 or 17, potentially in mid-2026, and that gives SpaceX several months to perfect both the ground infrastructure and the fleet of starships required for the massive operation. Confidence in this system doesn't rest only on hardware, though. It also comes from the leadership at SpaceX. Both Musk and Shotwell have spoken publicly about refilling, describing it as far less daunting than critics assume. They've compared the process to the automated docking of the Crew Dragon capsule with the ISS, something SpaceX has done with remarkable success for years. According to Musk, the refilling connections and procedures are similar or even simpler than Dragon's docking process, given that Starship's size allows for more robust systems. He's gone further, promising that SpaceX will attempt several refilling missions next year using the V3 vehicles. Meanwhile, other subtle but powerful clues have surfaced that point toward the parallel development of Starship HLS. One notable image from late 2024 showed a distinctive black and white airlock section within the Star Factory. Its unique coloration and internal structure suggest it could belong to the lunar variant. In a prior Starship test, Starship even displayed a corridor-like tunnel resembling the airlock passage astronauts would use to enter and exit the vehicle. The airlock is a vital subsystem. It's the threshold between the crew's living quarters and the lunar surface, the chamber through which astronauts will step out into the harsh gray dust of the moon. Seeing such a module within Starbase implies that SpaceX's engineers are not just thinking about refueling in flight. They're already refining the crew experience and life support integration for lunar operations. Then there's the the enigmatic black and white nose cone still resting at the production site. Some speculate it may conceal a fully equipped interior, perhaps a testbed for life support systems or even window placement experiments. SpaceX's habit of building functional mock-ups means this isn't far-fetched. It may very well be the first true glimpse of a lunar-capable Starship segment. And let's not forget one of the most fascinating systems under test, the Lunar Elevator. Over the years, SpaceX has quietly been refining a deployable platform designed to lower astronauts and cargo from Starship's towering hatch down to the moon's surface. Repeated tests and refinements of this mechanism demonstrate the company's steady, if understated, progress toward operational readiness. Taken together, these developments, which include S-39's refilling pins, the lunar airlock, the mysterious nose cone, and the elevator system, paint a picture of momentum. They show that SpaceX is not standing still but actively moving piece by piece toward the grand vision of returning humanity to the moon. So while skepticism remains, the signs are clear. The groundwork for Starship HLS is being laid with precision and purpose. The coming year could very well reveal the full architecture in action and bring us one step closer to watching astronauts once again leave footprints on lunar soil beneath the shining reflection of Earth above. Past few days have been some of the most turbulent for the Artemis program and for Starship's role within it since the lineup for the new race to the moon was first established. Yet Starship remains a truly unique vehicle, offering greater potential than any other system in development today. Recently, Musk once again revealed ambitious plans for Starship that could challenge NASA's decisions and possibly become the key to America's success on the lunar surface. So what exactly are Musk and SpaceX planning to achieve on the moon with Starship? And how do these capabilities surpass those of other vehicles? For many years now, the world has envisioned humanity's return to the moon aboard a massive vehicle known as Starship HLS, following its selection by NASA for the Artemis program. However, that expectation is now facing uncertainty, as Artemis 3 has suddenly turned into a competition, a race that SpaceX's Starship must win if it wishes to retain its place at the heart of the program. To understand how this situation developed, we must acknowledge one undeniable truth. Starship's progress has been slower and less predictable than many anticipated. For SpaceX to maintain its position, the company will need to accelerate Starship's progress. Yet faster development alone will not be enough. What has always set Starship apart is its extraordinary potential, the very reason NASA originally selected it for Artemis. If SpaceX can demonstrate that potential convincingly, Starship could still outshine every rival and secure its role in humanity's return to the moon. Recently, NASA official Sean Duffy pointed to Blue Origin as a strong competitor, noting its clearer progress toward a lunar lander capable of safely transporting a crew before China achieves its own landing. This suggestion clearly struck a chord with Musk, who responded on X by saying, "A permanently crewed lunar science base would be far more impressive than a repeat of what was already done incredibly well by Apollo in 1969. Musk's response reflects a critical shift in strategy for lunar exploration. Reaching the moon first is no longer the ultimate goal. Unlike the Apollo era, this new race is not about planting a flag and returning home. It's about staying. The focus has moved from short-term achievement to long-term presence. The new objective is to establish a permanent lunar base, develop resources, and begin the early steps of building an off-world civilization. This vision is not exclusive to Musk. It aligns with the broader ambitions of both the US and China. The nation that can establish a sustainable foothold on the moon will secure a strategic, technological, and economic advantage that far extends beyond symbolic victory. And when asked which vehicle can make this long-term lunar vision possible, the answer points clearly to Starship. Starship is unlike any spacecraft humanity has ever built. Even in its early forms, it towers over traditional rockets and landers. Standing over 50 meters tall and 9 meters in diameter, Starship is immense, and future versions, such as the V3 and V4, are expected to be even larger. This vast scale allows SpaceX to dedicate an enormous internal volume to cargo estimated at more than 1,000 cubic meters, which is greater than the total pressurized volume of the International Space Station. With this capacity, Starship HLS can carry more than 100 tons of payload, including supplies, scientific equipment, and even large-scale construction materials. Later versions could potentially double that capacity to 200 tons. In practical terms, a single Starship HLS flight could deliver as much cargo as dozens of smaller landers combined. This capability would dramatically accelerate lunar exploration, enabling early missions to carry not just astronauts, but the tools and materials needed to build a lasting presence. More importantly, Starship's immense capacity supports the creation of a lunar base almost immediately after the first landing. Instead of requiring dozens or even hundreds of smaller missions to ferry equipment piece by piece, a handful of Starship flights could establish the foundation of a large and functional lunar habitat. The construction of a fully equipped base, complete with power systems, laboratories, and living quarters, could unfold within just a few missions. This is where Starship's true advantage lies. Blue Origin's Blue Moon lander, while promising, operates under a more traditional design philosophy, one that prioritizes smaller payloads and incremental expansion. In fact, if SpaceX chooses, Starship itself could become a moon base. The idea, though ambitious, is technically feasible. By transitioning from a vertical landing configuration to a horizontal state on the surface, the spacecraft could be repurposed into a habitat. Such a conversion would require robust engineering solutions, such as support structures, internal reconfiguration systems,